This is fine-tuning Embeddings Model, a great way to boost performance of retrieval in a RAG pipeline, or boosting performance of other use cases of your Embeddings model. Now, I'm fine-tuning to boost my performance for my RAG application, which can be used using a LangChain or Llama index. But this video, I'm going to show you guys how to fine-tune the model. Now, the idea is that we're going to download our model first with the required packages and the environment. We will be using a Google Colab Pro Plus, just in case. We're going to be talking about the dataset, how to adapt it to your data. We're going to talk about the training arguments, important training arguments that you probably need to train that model, how to train it, and how to test the model. Is the embeddings model that we fine-tune any good? And of course, last but not least, actually saving the model and how you can do it in the most best way possible. Now, Sentence Transformer, for people who don't know, is a way to get embeddings in the most easiest way possible. So you can use various Hugging Face model to do that. And they just released the version 3 a few days ago. And this is the most simplest way to get embeddings from texts that are extremely useful. Now, let's get on with our training. So first, you have to make sure you have downloaded all the packages that are listed over here. By the way, I am using an L4 GPU from Google Colab, if in case people were thinking about. By the way, I make similar videos like these on LLMs, machine learning, and other data science tools. So please feel free to subscribe. Now we have installed our packages. Now we're going to load our dataset. So I'm just going to run this real quick. By the way, we are going to be fine-tuning a BGE large model, which is one of the popular models for getting embeddings or getting features from, and is commonly used for retrieval augmented generation pipelines. But this can also work with nomic embedding as well, if you guys are interested into that. So two of the most popular embeddings model that you probably use for your LangChain or Llama index RAG pipelines. Nevertheless, we're going to load our dataset for training our embeddings with 55,000 data points. And this is interesting because I'm going to show you guys how easy and fast it is to train an embeddings model compared to a generative use case. Now, when it comes to dataset, let's talk about how the dataset should look like. How can you adapt it to your data, or how should you organize your data to train an embeddings model? Now, we'll be using a triplet dataset over here. And if we inspect it real quick, it looks like this. You have the anchor, the positive, and the negative. So the anchor over here essentially means that it is the original sentence for the query. Now, considering that I'm here trying to optimize this embeddings model for my RAG pipelines, so I'm going to have a dataset with anchor, the original sentence or query, and then I'm going to have the positive answer, which is, as you guessed it, a correct or relevant response to the anchor. So the embeddings that I want based upon my query. And I will also give an example for a badly retrieved information so that the model knows, hey, do not use this, or try not to get these types of embeddings for my data. And that is how you can organize your dataset to train the model. And to train your embeddings model, you don't necessarily have to have a triplet dataset. You can have a pair, so you can have two different pairs of data. For example, so you have the anchor positive. You can have a pair class, so you can have premise, hypothesis, and a label with this neutral contradiction or something. Or you can have a pair score, so have a floating point label to your sentences to see how similar or dissimilar they are. So different ways to train your embeddings model. And now we're going to go back to our code. We're going to load our model. Now, as mentioned, we are going to be using a BAI, BGE large model, which is probably one of the more popular models to use. And because they just updated the library recently, because the Hugging Face team actually took over the Sentence Transformer library recently, they're allowing to fine-tune various new embeddings model that comes out. So this pipeline can be used for newer open source models that comes out. Now, we have downloaded our model. Now we're going to set up our training arguments. So we're going to import this. Now first, we're going to define a loss function using our model, and then we're going to specify our training arguments. Now you have to make sure the output directory is set, so defining where the model will be saved in your local directory. So in this case over here, we're going to specify how many epochs it's going to run, the batch sizes, different warm-up ratios, and these are things you can trial and error with to see if it improves or degrades the performance of the fine-tuned model. So the training arguments is set, and now we are going to train the model. Now we set up the trainer, and now we are going to train our model. As you can see, training around 5,000 samples on an L4 GPU on Google Colab takes around 2 minutes or less to train the model, which is extremely fast. Now, this is a strong or stark comparison to how these generative models take so much time and the GPU resources. This is way more faster and simple way to improve your performance of your embeddings model, whether you're using it for classification or your RAG pipelines. Now we are almost finished with the training. We're getting the training loss and the validation loss with various steps. And here we go. Now for the most fun part, or in my opinion, the more important part, is to see if our newly trained embeddings model is any good. Now, at the end, we should be able to see a dictionary with different accuracies, dot product accuracy, different distant metrics accuracies. And to do that, all we have to do is import this triplet evaluator, which the SentenceTransformer team have kindly given us. Here you pass in your test data with the different columns. And of course you put a name over here and you pass in the test evaluator model or instantiated. And here we go. Here are the different metrics. So here we got almost 90% on the cosine accuracy, 11% on the dot product accuracy, and various other things. Of course, this can be improved, these numbers, if you just train it more, give it more data, or maybe less data. You never know. But yeah, there's a way to quickly test to see if embeddings model is any good. Now for the bonus part, to see how we can actually save the model. Now the model is actually saved on your content directory in your Google Colab with different checkpoints and everything. However, what if you want to save it somewhere else? In my opinion, probably one of the best ways to do it is to actually save it in the Hugging Face repository. It's a repository that allows you to store your really large multi-gigabyte model files for pretty much for free. So here I've provided the code. Make sure to log into Hugging Face CLI to be able to save those models. I'm not going to run that, but I just given this as a support and help. All right, guys, that is how to fine-tune embeddings model so you can use to optimize your workflows. All right, guys, this is Mosley. I really hope you guys found it insightful. If you guys did, please feel free to subscribe, and I will see you in my next video. Have a nice day.